Okay, so you can check that the geometrical isomerism is shown by. So which of the following will show you have a restricted bond here, double bond, two hydrogens here, no different groups on either side. Condition number 1, restricted rotation. Condition number 2, different groups on either side of the restricted system. So two hydrogens here, no GI possible. Similarly, this one also, you have two hydrogens here, no GI possible. Here also two chlorines, no GI possible. But here you have CHCl. And this side, if you see, you have this group which has a carbon. You have this group which is a carbon. So in such case, go to another one till the time there is some point of difference. Let's move ahead. We go here, there's this carbon. We go here, there is this carbon with CH3. There is a point of difference. So yes, it can show GI. Answer to this question becomes option D. All right. Moving ahead, another question waiting for you. Which of the following compounds will exhibit cis-trans? This is going to give you a good practice of IUPAC nomenclature as well. But2-ene you have. But2-ene, butanol, but2-ine, butane-2-ol. So do you understand? We have to see doubly bonded system if it is there, or any restricted system. So doubly bonded system present, yes. Different groups, yeah. One hydrogen, one CH3, one hydrogen, one CH3. Cis and trans are possible. A is absolutely right. Next question, rapid fire. Which of the following compounds have restricted rotation? Now it's asking which has a restricted rotation. Tell me. Is doubly bonded a restricted rotation? Now you don't have to check whether GI is possible. The question is very simple. Will it have the restricted rotation or not? A cyclosystem also is a restricted system. If you try to rotate it, the cycle will break, the ring will break. So that is also a restricted system. Okay, N double bond N. Here you have, of course, the lone pair which is going to determine, like we discussed, the azo group is very much a restricted system and can show GI. So all of the above becomes the answer. Good question to recap what we have done. Next one, what about this one? Which exhibits cis-trans isomerism? Which will show cis-trans? Let's see. Okay, so you can see that no restricted rotation, no restricted bond here in A, no restricted bond here in B. Here you have restricted bond, which is carbon double bond carbon, and it has different groups on either side of the restricted system. So C can, of course, be your answer. D has no restricted rotation. So C becomes the answer. Another rapid fire. Please be very quick in this one. Which of the following has cis configuration at each double bond? You have to check now the configuration at each double bond. You can see, you can start with the first, second, third and fourth. These are the options. Check, check, check. At all, the moment you see a double bond, a methyl and a methyl, this is a cis. You can see double bond. This group is here, this group is here. If you're confused, just draw hydrogens and it will make your life simple. Okay. So you can see out here hydrogen, and this is a different group which is here. So this is a cis, this is also a cis. What about this? This is also a cis. You have a methyl and a methyl group here. Don't you agree? Will you call this system as a cis and a trans? Cis, cis, cis. Okay. This is a trans, trans, trans and trans. No objection on that. This is a cis, 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 cis. No objection on that. This is a cis, but this is a trans. This is a cis and this is also a cis. You have one double bond which is a trans. So out here, first and third one are showing you the cis configuration. So please see, D becomes the answer. The first one gets a little wrong where students find it difficult to decide, but I hope it is clear. You can check on the basis of Hydrogens in case of this double bond, check for methyls in this kind of a system. Check for again methyl in this system. So cis, cis and cis, we have D becoming the answer. Next one. Okay. Which one of the following exhibits cis-trans? Another simple question. Previous year question. Let's check. Rapid fire. Okay, so you can see that methyl and a methyl on the same site, cis again, and trans can be possible. Okay, doubly bonded system, different groups, doubly bonded system, but the same hydrogen, so B cannot show doubly bonded system, same groups on either side cannot show doubly bonded system, but same hydrogens on the right side cannot show, so A becomes the answer to this one. You guys are wonderful. Okay, another one which is going to give you a practice of geometrical isomerism as well as IUPAC nomenclature, which will exhibit geometrical isomerism. You have 2-methyl propene, you have hex 2-ene, you have butene, but 2-methyl but2-ene, you have propene. Please tell me which one will be the answer. Clearly you can see that if you actually look at the first one, you have the 2 hydrogens on the same side and 2 methyls on the same side. So A cannot be your answer. Yeah, it's B, because you can see double bond here. One is CH3 and one is hydrogen, different groups. One is the propyl and one is the hydrogen, different groups. B becomes the answer to this question. Simple one, good one, simple one. Again, it will give you a practice of nomenclature as well. Try this one as well. Try it out. 1,1-diphenyl prop-1-ene. So the moment you draw it, you would know that that cannot be your answer. Pent-1-ene, the moment you're making 3-phenyl pent-1-ene, you can see that the first carbon is a problem. 2 hydrogens attached to the first carbon. Let's see pent-1-ene, but 2-phenyl. Will that make a difference? No, it will not. At least these hydrogens are same. So even C cannot be your answer. What about D? 1-phenyl pent-2-ene. The moment you have a pent-2-ene, I think that can actually solve our purpose. 1-phenyl pent-2-ene. Of course, different groups on right and left. Doubly bonded system. D is indeed the right answer. Okay, I hope you could match with the pace. It was actually like a rapid fire. Another one we can do very quickly, like a rapid fire. Which of the following structures will not show geometrical isomerism? Not show. So now I am sure the clarity on oximes is already high definition, crystal clear, that one of the groups is to be considered for a lone pair, right? Will not show. So these oxime kind of systems will show geometrical isomers. This doubly bonded system, different groups will show. Here also you have H and Br, CH3 and H, different groups, doubly bonded system will show. But the moment you see 2 same groups on either side of the restricted system, that will not show GI. D becomes the answer for this question. Okay. Okie dokie. The incorrect statement regarding geometrical isomerism is option A, restricted rotation about double bond or ring. Groups that are responsible to show geometrical isomerism differ in their relative distance. Free rotation about sigma bond or single bond. Free rotation. No, we're not talking about conformational isomers. 2 different groups at both atoms of restricted bond. Of course, that's one of the conditions. C is indeed absolutely wrong. So C becomes the answer for this question. Okay. All right. Okay, this is the last one from this topic of geometrical isomerism. Let's see. You have to tell in which of the following the double bonds are marked as 1, 2, 3 and 4. Geometrical isomerism is not possible at those sites. Which of the sites? So now look at the first site, the second site, the third site and the fourth site and decide your answer. Check, check, check. What do you say? A, everybody agrees with A. The moment you see 2-methyl, you know that. The first one will not show, but let's check the second site also. You have double bond, different groups here and different groups here. Yes, it can show different groups. Third can also show. Fourth one, interestingly, has ethyl and a methyl different group. Methyl in this whole group, different group. So yes, it's just the first site which is not going to show GI, rest all will. Okay. Please do let me know in the chat how many of the geometrical isomers are possible here. How many GIs are possible? How many GIs are possible? Let me know in the comments. Okay.